Greetings, Murgatroyd maniacs. In my last video, I talked about all the changes I made to the Murgatroyd recently, and in particular with regard to the slip rings. In this video, I'm going to be talking more about the slip rings in order to give you more information that I didn't present in my last video. And forgive me because in this video, I erroneously call the slip rings spin rings. So just ignore that and just replace spin rings with slip rings and everything will be copacetic from here on. Please enjoy. Thanks. So this episode will be devoted entirely to talking about the spin rings and some of the recent changes I've made relative to that. And to get started, let's just talk a little bit about the history of the Murgatroyd and how the spin ring came about. This, as you might recall, is the very first model of the Murgatroyd that I built, the Murgatroyd 1. This model was powered by a 12-volt battery, which sat inside this huge box along with a microprocessor, and powered the Murgatroyd for about 15 minutes before needing to be recharged through that port there. After I had that going, I was very pleased with the operation of the Murgatroyd, but I realized it needed continuous power. And I thought about it some, and I realized that a ball bearing might be able to do the job. So I found this ball bearing here. It's called a pillow block bearing. And the inner and outer of the ball bearing connects by the ball such that I can conduct electricity from the spinning inner to the static outer. And I have, what I did is create another electrode in addition to the shaft of the motor shaft ended up being a good connection for ground. And this other middle of the ball bearing was going to be the second connection for the positive terminal. And the shaft for the motor passed through the ball bearing without actually touching the middle rotation of the ball bearing. So I was able to provide power that way. It worked well enough. It was not entirely consistent. In other words, the ball inside did not always make good connection with the outer ring of the ball bearing. And so occasionally I would get power on resets. And that actually became worse over time with different bearings that I purchased from Amazon seemed to conduct worse than some of the initial ones that I bought. So at that point, I found on Amazon this thing called the spin ring, which I've showed in the past. The spin rings have a number of wires, and they of course have a spinning spin one side and the other side is static. And in the case of the Murgatroyd, what I did is mounted it kind of upside down, and I mounted the static portion of the spin ring to the spinning head, and the shaft of the motor would pass through the spin ring and connect to the connection here. You'll see there's the 1/4-inch motor shaft connector here on the Murgatroyd box. And this worked pretty good. 6 rings provided enough power to the Murgatroyd when I doubled up or some of the rings. The 6 wires were partitioned such that I had 2 12 volts and two grounds, and that's four spin rings, and then had one for the Hall sensor to pass down into the base, and then one more possibly could be used for audio sharing grounds with the panels. And it may still be possible to use this 6-wire spin ring, but I found that what I really wanted to try to do was to go to a static microprocessor, wherein the microprocessor, instead of being spun around, could be located in the base of the Murgatroyd. In order to locate the microprocessor in the base of the Murgatroyd, that meant that I had to pass the LED panel data through the spin ring, and in addition to the power and other signals. So 6 rings wasn't going to do it. I looked at using 12-ring spin ring. By the way, these spin rings are made by Moflon, M-O-F-L-O-N, and I'm using the MT1256 series of spin rings. With the microprocessor in the base, in the stationary base, I would partition the 12 wires as 3 power, 3 ground, 4 panel data, and 2 for 5 volts and ground to supply the microprocessor in the base. And that's with a stationary microprocessor in the base. It's also possible to use that same 12-wire spin ring to power a spinning microprocessor. And in that case, I used 4 power and 4 ground, 2 rings for the Hall sensor and 2 for audio. And either of these 2 configurations work okay. There is one difference though, in that I've noticed that with the microprocessor located in the base, occasionally I'm seeing erroneous LEDs lighting and erroneous data. This could be due to noise in the spin ring, could be due to bad panel. I'm really not sure at the moment. Could be the drive to the panel, and I'm looking into that, trying to understand it. And but at the moment, I decided to just use that for the test base where the microprocessor is static, and to continue spinning the microprocessor in the head. The 12-wire spin ring is 17 millimeters longer, and that caused a good number of problems. The motor shaft that you get from the motor manufacturers are not long enough, would not be long enough to pass through the spin ring and connect to the Murgatroyd. So that meant we needed to extend the motor shaft and add a motor shaft coupler. And at that time, we decided to change the motor shaft itself from a 1/4 inch to 12 millimeters to be consistent with the bore hole of the 12-wire spin ring. The 6-wire spin ring had a 10 millimeter bore hole. But in any case, at the time we also decided to connect the spin ring itself to the motor shaft, where previously the motor shaft just passed through the bore hole of the spin ring and didn't connect. So that all required a good bit of work on Keith's part to make the shaft coupler, to cut the new shaft to the right length, and then to center it on the Murgatroyd box, which has had a new 12 millimeter motor shaft connection to the main box. And Keith had to do that at the same time while keeping everything perfectly centered so that when it rotated, we didn't get any excess vibration. So I really give him a lot of credit for the work that he did, because the units, both of the test bench and the main Murgatroyd, don't vibrate very much at all while spinning, which is awesome. So this is this 12-wire spin ring as mounted on the test base. And you can see here, this is the motor shaft coupler going from 1/4 inch motor shaft to the 12 millimeter motor shaft, as well as the new coupler, the 12 millimeter coupler to the main box of the Murgatroyd. And Keith had to add these stator supports that basically anchor the main slip ring stator so that it remains stationary as the top portion of the slip ring spins. And you can see this is a lot larger in length than the other one that I was using, the 6-wire spin ring. You can see a result of the increase in height of that spin ring caused the hex base to have to be raised up, which I'll show you right now. I mentioned that I had to raise up the infinity structure in order to accommodate the increased height of the spin ring. And this black band is what I added to the infinity structure. It raises up the hood, so now it's cleared by the top of the panels. It's no longer, it was up way too close to the very top of the infinity structure, but because of this, it raises it up. It also provides a nice structural support to the infinity structure, so I can take it on and off without having to worry about the glue loosening. As I mentioned in my last video, adding extra spin rings has caused more friction for the rotation of the motor. And because of that, I had to add another relay, motor control relay, which would only activate when I tried to spin up the Murgatroyd. And that fixed that issue. While investigating the spin rings, I found some information in the data sheet I had not noticed before, which is that these rings are only spec'd to have a lifetime of about 20 million revolutions. Well, that sounds like a lot, 20 million revolutions, if you think about the fact that the Murgatroyd spins at 330 revolutions per minute. 20 million revolutions corresponds to about 1,000 hours, which is basically 42 days of continuous spinning, which is actually a lot less than I had originally hoped for. Turns out that this company makes more expensive spin ring models. The most expensive one, which I believe uses all gold contacts, is rated at 150 million revolutions before failure. And that corresponds to about 315 days, which is almost a year, but still a lot less than I had hoped for. So because of this, I decided that I'm going to be adding a motion sensor to the Murgatroyd so that the Murgatroyd will only spin up when somebody's in the area. And that should greatly extend the lifetime of the spin ring. The other thing with regard to the spin ring is that you notice that all the power and grounds, I've always been using more than one ring. And so the redundancy of having more rings for power and ground should also greatly improve the lifetime of the spin ring. So that's pretty much all I know at this point about the spin rings, and I hope that if you ever do try to build your own Murgatroyd, you spend some time looking into this yourself and come up with perhaps a different model, but basically now you get to understand some of the issues related to that. Thanks again for watching. Bye-bye.